All right, so today we're doing 5.6b using quadratic equations, which is our real world problem examples. So our first problem that we have is from the time Mark Twain wrote The Celebrated Jumping Frog of Calaveras County in 1865, frog jumping competitions have been growing in popularity. The graph shows a function of modeling the height of one's frog jump, where x is the distance in feet from the jump start. So here we know that x is our distance based on what we read, and we know that y is the height, how high it jumped, right? And so from there, we kind of have established what the domain and range represent. And then it gives us an equation here. So it gives us an equation here to use to help us solve these following problems. Notice it's a quadratic equation. So it says, how far did the frog jump? So if I'm looking for distance, that means I'm looking for the values of x, right? If I want to know how far did it jump, notice that I'm going from here, which is 0, to here, okay? What they have in common is that the height is at 0 feet. So the height is at 0 feet. So I know that this, I'm solving for when 29,000 squared, x squared, plus 5,900 x equals 0. Okay, and so to solve this, we're going to do what we did yesterday, which was factor. So we're going to factor and solve. So starting off, I'm going to factor what they have in common. I'm going to factor out a negative x, and that's going to leave me with 29,000 x minus 5,900 equals 0. Okay, I'm going to use the zero property theorem, and I know that negative x equals 0, and I have 29 thousandths x minus 5,900 equals 0. This one's pretty easy. X has to equal 0. This one, I'm going to use two-step operations, and I'm going to add, and then I'm going to divide. So I add 5,900, and then I'm going to divide by 29 thousandths. Okay, and that's going to give me x equals. So literally, I'm following the two steps that I said I'm going to follow, type it in the calculator, and I get a number. And I get approximately, let's make this an approximation. So we have approximately 20 and 34 hundredths. Okay? So since we have 20 and 34 hundredths, again, x represents the distance. So how far did the frog jump? Well, the frog jumped 20 and 34 hundredths feet. Okay? Next, it says, how high did the frog jump? So if we're looking for how high the frog jumped, then we are looking for the vertex. So we're looking for the vertex. And when we talked about this before, to find the vertex, remember it's negative b divided by 2a, comma, negative. You find that value, you're going to plug it in, and that gives you your vertex. Okay, so in order to do b, first thing we have to do is find the x value of the vertex, plug it in to find the y value of the vertex, to know how high did the frog jump. Okay, so from our equation, we know that a equals negative 29 thousandths and b equals positive 5,9 hundredths. We're going to plug them in, and remember the vertex x equals negative b divided by 2a. So negative 5,9 hundredths divided by 2 times negative 29 thousandths. We plug that in the calculator, and we get 10 and 7, approximately, let me do that again, 10 and 17 hundredths. So what you notice here, it would make sense, right? So if my distance was 20 and 34 hundredths, Well, if I'm looking for my vertex, it's halfway in the middle. And notice, what did we get? 10 and 1700ths. So we know that we did that right. To find how high the frog jumped, we're going to plug that in. So we have f of 10 and 1700ths. And we're going to plug that in for x. So we have negative 29 thousandths times 10 and 1700 squared plus 59 hundredths times 10 and 17. So we plug all of that into the calculator. So when you plug it all into the calculator, you're going to follow your order of operations. We're going to square first. So when we square first, what do we get? We get 103 and approximately 43 hundredths. And then we're going to times that by negative 29 thousandths. And then we're going to add that to 59 times 1017. Okay, so once we type all that in the calculator, get that done, we should end up with approximately 3. So the frog jumped 3 feet at its highest. Okay, so this was asking about the domain and range here. So if I'm looking at the domain and range, so my domain is based on my distance and my range is based on my height that I jumped. So the domain and range for this would be domain, so part C. My domain would be 0 to about 20 and 34 hundredths. And my range would be from 0 to about 3 feet. And that's real world problem number 1. All right, example number 2, we have the function y equals negative 300 x squared plus 1 and 6/10 x models the path of a kicked soccer ball. The height is y, the distance is x, and the units are meters. How far does the soccer ball travel? How high does the soccer ball travel? How high does the soccer ball go? Describe reasonable domain and range for the function. So again, we're real world, quadrant 1. So the soccer ball is kicked. It goes like that. That's not the best picture. Let's do that again. So let's try that again. So soccer ball is kicked and it's gone, right? What goes up must come down, right? So this is roughly my vertex is where it's going to be at its highest. And here's when it's on the ground. Okay, and it says that x, the height, again, is my y, and the distance is my x. Does this problem change any different than what we just did? No, it doesn't at all. So it says, how far does the ball travel? So I'm looking for the distance. And when I'm looking at the distance, when it's traveling, overall, it's from being on the ground to coming back to the ground. So again, we're setting it up as 0 equals negative 300 x squared plus 1 and 16 x. Notice it's a negative, and the reason why it's negative is because we have a negative quadratic, a negative parabola, right? It's concave down, so it's going to be negative. So just like we did before, we're going to factor. So we're going to factor, and we can factor out a negative x, and we're left with 3 hundredths x plus 1 and 6. Not plus. We factor out a negative. A positive becomes a negative. And this equals 0. So like we said, you're going to take your negative x, set it equal to 0. Take your factor, your binomial factor, and set it equal to 0. So obviously we know x equals 0. We knew that because it started at 0 distance. And now we're going to do our two-step. So that means adding 1/16, dividing 300ths to get our x values. So we have x equals 1 6/10 divided by 300ths. So if I have 1 6/10 divided by 300ths, I get approximately 53 1/3 exactly. It's not letting me write, y'all. So we get 53 1/3 as our distance. So the ball traveled 53 1/3 meters. Sorry. All right. It now wants to know, how high does the soccer ball go? What we talked about on the last problem is that if this total distance is one thing, so this is 53 1/3, this has to be the halfway mark. So instead of having to use the vertex formula, we can just simply find our x where this takes place by dividing this in half. So this would be 53 1/3 divided in half. And that would tell us our height. So to find our height, we have f of 53 divided by 2, which is approximately, let's say, it's 26 2/3, so we're just going to make it easy for ourselves and say 26 67/100ths. And we're going to plug this into our equation. So plugging it into the equation, what do we get? So we have negative 300ths times 26 67/100 squared plus 1 6/10 times 26 67/100. All right, so we type that all into our calculator. Again, remember, following your order of operations, I'm going to square, multiply, then add. And so once I've done all of that, I end up with 21 1/3 meters. So how high did the ball go? Meters. That is how high the ball went in the air. And then the last piece, it says, what's the domain and range? So my domain for here, the ball starts at 0 feet and it ends at 53 1/3 feet. The range for this, the ball started on the ground at 0 and it goes as high as 21 1/3. And that's that. All right, formula. So we have an interest formula here. And it says, using the formula A equals P times 1 plus R to the T, find the rate at which 600 grows to 739 in years. So our formula is pretty self-explanatory. What P stands for, it's called our principal, and your principal is, what do you start with? So P is our principal. What am I starting with? Well, I'm starting with $600. Okay? And A is what you have accumulated over time, and I want it to grow to 739. So this is my A. And it wants me to find my R. So I'm going to plug everything in. So again, we have A equals P times 1 plus R to the T. And oh, our T is right here. It's 2 years. So we're going to plug in everything that we know. So we know A, which is 739, equals P, which is 600, 1 plus, we don't know, our R, and T. And our T is squared. Okay, so this problem is leading us into what we're doing tomorrow, and it's going a little backwards. So instead of squaring and factoring, what would I have to do to get rid of this square? If you said take the square root, that is correct. So we're using inverse operations. And the inverse of x squared is to take the square root of it, right? That's how we get rid of that. So I'm going to divide by 600. Okay, so just typing that in, and I'm going to get approximately 1 and let's go to the nearest thousands. So we get 1 and 232 thousandths equals 1 plus r squared. And like we said, we have a square. The opposite of squaring is to take the square root. I'm going to eliminate. So I take the square root of that. And when I take the square root, what do we approximately get? Or we end up with approximately 1. I'm just going to 111. 1 and 11 hundredths equals 1 plus r. So then to find the rate, we just now have to subtract 1, and we have equals our rate. So that means that it's at an 11%, approximately an 11% is what the rate would have to be. Okay, this again is a lead-in for tomorrow. Okay, so here we have the distance st in feet traveled by a freely falling object is given by the function s of t equals 16t squared, where t is time in seconds. Use the formula to find the time it would take for an object to fall to the ground from a cliff that is 1,600 feet high. Okay, so again, on this one, we have our t is our time in seconds, and our height, that is our, this is our height, and it's in feet. Okay, and it wants to know how long will it take for an object to fall to the ground from a cliff that is 1,600 feet high. Okay, so we're going to say, we're going to plug in. So we have s of t equals 1,600. And we want to know it equals 16t squared. So again, we're practicing inverse operations. So I'm going to divide by 16, and we get 100 equals t squared. We're going to take the square root of t squared, and we get 10 equals t. So how long will it take? Approximately 10 seconds. Well, theoretically, algebraically, 10 seconds. In the real world, there are other factors that could make it take longer. All right, here, the area of a square porch is 64 square feet. Find the dimensions of the square porch. Remember, what makes a square square is that all sides are congruent. There you go. So you know that's a square. And I know that the area of a square, if I have x, area equals x squared. So we created our own equation. So we have area equals x squared. Here, the square porch is 64 square feet. Find the dimension. So we have 64 equals x squared. Easy enough. Take the square root, and we get 8 equals x. Okay? 8. Now, yes, I just want to remind you, yes, when we take the square root of x squared, yes, it does produce a plus and minus x. But because this is real world, you got to be mindful. Are you going to have a negative 8 feet? No. So we got to use a little bit of math sense and know that we're looking at the positive root, not the negative root, okay? Our last one, a common equation used in business is a demand equation. It expresses the relationship between the unit price of some commodity and the quantity demanded. In the demand equation, we have P equals negative x squared plus 108 for a certain style of calculator. P is the price per calculator in dollars, and X is the quantity demanded in thousands. Find the demand for a calculator if the price is $8 per calculator, okay? So we're going to establish what's given to us. We know our P, because P is the price per calculator. And then we got to find the demand, and our demand is X. So we have P equals negative x squared plus 108. And we're going to plug in what we know. We know that P is 8. We're looking for x squared. And so we're going to go and begin. So we are subtracting 108. That gives us negative 100 equals negative x squared. Change signs because we divide or multiply by a negative. And now we can take the square root. So x equals 10. And again, real world. So what's the demand for the calculators? It's not just 10, it's actually 10 thousandths. Labels are important. All right, so that concludes our word problem examples. Your classwork/homework is on Canvas. You have plenty of time in class to work on it, so use your time wisely.